Hey guys, in this video I'm going to be going over my conductivity, temperature, and depth sensor for my Spacecraft II project. So for this project I used a toroidal conductivity sensor design. This design makes it so the circuitry does not actually need to touch the fluid, so it's good for corrosive fluids. The sensor also uses a Type K thermocouple and a linear pressure transducer that is capable of reading up to 30 psi. Then on the main controller board we have the circuitry powering the conductivity sensor. To generate an AC current we have a Wine bridge oscillator that generates a frequency of roughly 3.4 kilohertz. Powering the Wine bridge oscillator I have two 9-volt batteries put in series with the negative of one and the positive of another going to ground, so the negative of one can power the negative supply and the positive of the other can power the positive supply for the Wine bridge. Then coming back from the sense toroid of the conductivity sensor we have a non-inverting amplifier using another 741 op amp, which then goes to a full wave rectifier having a large capacitor, 1 microfarad, to smooth out the output to have a smooth signal. So looking at the housing design for the conductivity sensor, I have a shield up here. As with the previous version, when I would put the thermocouple in the water, it would cause both the conductivity sensor and the thermocouple to short with each other, resulting in both values being very wrong. However, with this new version, I realized previously there was a water leak in the conductivity sensor. As we can see with the previous toroid, there's corrosion all over it. So this new version has a plug in the center, compression fitting in between the two halves. Unfortunately, with this new design, it was discovered that the magnetic fields generated are not strong enough to be sensed by the sense toroid, so stronger electronics would be needed for that. And then finally, to convert the temperature into a digital measurement, we have the MAX 6675 digital converter. And then just an Arduino Uno powering it with two analog inputs and a digital input from the temperature sensor. Finally, we have the code powering the electronics, with at the bottom we have the temperature, the pressure in kPa and gauge, and the conductivity. As we can see, the conductivity reads 0 even when putting it in a high salinity fluid. That has been an overview of the conductivity, temperature, and depth sensor I created. I hope you enjoy. Side note on the construction of the whole controller base, this whole base is 3D printed, as we can see, and it has a center channel to help guide all the wiring.